Maybe you've heard of functions before. Maybe you've written functions in various programming languages. But what is a function? What happens under the hood in the computer when we call a function? The way this is going to go is we're going to look at some C++ shell code that basically just calls a simple function written in assembly. And all the shellcode does is sets up some variables to be passed into and out of the function, as well as call a print before and after the function call to see the results, to see how the function changes the variables. So here's what the assembly code looks like for a function that we're going to call. And this here, I have a lot more going on here than we're actually using, because this kind of shows a nice template for generic calling of a function using x86 architecture, the C calling convention, and the MASM assembler. But if you'll notice where the semicolons are, those are comments, and most of this is actually commented out because it's not needed for the very basic function that I'm about to use. And so this is what a very simple function looks like when I remove the comments, because a lot of that functionality we're not using in this very simple example. Lines 2, 3, and 4 are just kind of setting up so that the compiler knows how to handle our source code. Our function starts with line 6, my func proc. Lines 14 and 15 end the function, my func endp and end. And then we set up our call stack with push EBP and move ESP into EBP, and then we clean up our call stack at the end with pop EBP and return, and then the only actual line of our function is just taking our input parameter, which is EBP plus 8, and moving it into EAX, which the return value needs to go in EAX by this calling convention. So that's the value that's ready to be returned after the function call. Now we're going to take the last couple slides here to just really quickly step through this short function and see how it operates. I mentioned this earlier, but now I just want to highlight it. If we start in the C code, that's the kind of the shell code that's going to call our function, the first thing that we do is we have printf, where we print what I have circled in red there that shows what it prints to the console before the function even runs. So before the function actually runs, it tells you the values. So before the function a is equal to 0 and the return value rv is equal to 1. You see our code right here, and we're going to step through that. So after we start it, on the right hand here you see the registers and their current values. In the middle here you see some values of some memory addresses, and the addresses that it's pointing to right now are outside of the scope of this program, so the values are hidden from us. And then on the left hand side here you see the code and the line we're at. So right now we're at push EBP. So after I step to the next step, it's going to change, it's going to push EBP, which will change the value of the stack pointer here. So you see the instruction pointer changes every time, but you'll see that the stack pointer value changed. The next one, we move the stack pointer value into EBP, so you'll see that happen. And now if we take this base pointer value, this is a memory address, and this points to the base of our stack. So now we know what that is. And from there we can see, so this is the return address for the, this is the contents of the base of our stack, and then this is the address of our base of our stack here on the left. And then going downwards from here, this next value here, which would be EBP plus 4, this is the return address that will get us back to where our call came from. But you actually read these the bytes from right to left. So this address is actually 00031982. And then the next value here is EBP plus 8. And this represents our first parameter that was passed into our function, which in this case is the only parameter, the A value, which was 0. So that's why you see a 0 in here. So when we step into our next line here, we moved EBP plus 8 into EAX. So EAX, which it happened to already be 0 in this case, but if it was not 0, it would have changed that to 0. And EAX is where our return value goes when we're getting ready to exit our function and give control back to the C shell code that called us. That's where it's going to look for the return value, is in the EAX register. So then our next line here is to pop EBP to clean up that base pointer, to get us back to get the base and the stack pointers back to what they need to be to hand control back to the calling C code. And we return, and we're back into our C code now. And finally, after we finish running our function, we return control back to the C shell code that called our function, and then the C code is going to print the second line here for the second value. And you'll see, so before we passed into our function, we had the return value was a 1, and the value we passed into the function as a parameter was 0, and then the function took that 0 and made that the return value. So after we call the function, you'll see that the return value changed to 0.